guys, this is question MM133 of the Maths Methods Fortify study guide. So we've got this question, it's an application question. We've got the mean daily maximum temperature in Melbourne in 2016 is modeled by the function T of T equals 24 plus 12 cos of pi T over 6, where T is between 0 and 12, not including 12. Big T is the temperature in degrees Celsius, and little t is our months after 1st of January. Sweet. Now, our question asks us, our very first question, what was the highest mean daily maximum temperature that occurred in 2016, and in which month did it occur? So guys, there's multiple ways of doing this question. You can simply sketch it on your graph, sketch the graph on your CAS and see where the maximum temperatures occurred. You can do it algebraically, whichever way you kind of feel like. So I'm going to do it today algebraically just to show you sort of what it looks like, and then you can kind of work out your own way of what you think is best. So, our maximum temperature, the way that I'm going to do it today is work out what the maximum temperature is and then figure out where that value occurs. So our maximum temperature is equal to our midpoint, which is 24, plus our amplitude, which is 12. So our max is equal to 36 degrees Celsius. Cool. Now what we're going to do is actually figure out when this value of 36 occurs. So we have 36 equals 24 plus 12 cos of pi t on 6. And rearranging this, we get 12 divided by 12 is 1. So 1 equals cos pi t over 6. Pi t over 6 equals inverse cos of 1, which is equal to 0, which means that t equals 0. This could also come out as t equals 12, but our domain does not include 12, so it can't be 12. So t has to equal 0. And guys, we have to really make sure that we answer the question here. So the question is asking us, what was the highest mean daily maximum temperature? So our max equals 36 degrees Celsius. And in which month did it occur? In t equals 0, which is January, because our time is t months after 1st of January 2016. So January 2016. So guys, your first mark comes when you recognize that the max is 36, and you plug that in there, and your second mark comes here where you write down your answer. That's part A, guys. Let's jump straight into part B, and as always, just hit me up if you have any questions. Sorry, I keep rubbing out these questions, which I should not be doing. Just so that we have this here, T of T equals 24 plus 12 cos of pi T over 6. Cool, and we're going to move on to part B now. So, part B, what have we got? We've got, what was the mean daily maximum temperature on the 1st of April 2016? So guys, keeping in mind that our little t is the amount of months after 1st of January. So on the 1st of April, that's the 4th month, which means that it's 3 months after the 1st of January. So we've got the 1st of January here, 1st of Feb, 1st of March, 1st of April. So t equals 1, 2, and 3. So all we need to figure out is t of 3. So if t of t equals this, our t of 3 is simply the same, but we're replacing t with 3. So 3 pi on 6. What this gives us is 24 plus 12 cos of pi on 2. Cos of pi on 2 equals 0. Which means that this whole thing here equals 0, which means that t of 3 is equal to 24 degrees Celsius. Do not forget your units, the degrees Celsius, or you'll be incorrect because it's asking for temperature. It's a 1-mark question, so that's your first mark. That's part B, guys. Jumping straight into part C. I'm going to do this over here because I can have the space. And the question's asking us, in which month does the mean daily maximum temperature in Melbourne first lower to 18 degrees Celsius? So we're basically doing the opposite of what we did here. So here we subbed in a t value, like a little t value, whereas now we know that the big T is 18 degrees Celsius. So we're going to sub in 18 here. So 18 equals 24 plus 12 cos of pi t on 6. And rearranging this, 18 minus 24 is negative 6. Divide that by 12 is negative 1 on 2, which equals cos pi t on 6. inverse cos of negative 1 on 2 equals pi t on 6. And from here, we get inverse cos of negative 1/2 is 2 pi over 3. 2 pi over 3 equals pi t over 6. And rearranging this, we get t is equal to 4. So this is our first mark because we haven't actually answered the question. So we've got the answer t equals 4, but the question is asking us in which month does the mean daily maximum temperature first lower, which means that when t equals 4, 18 degrees Celsius first occurs in May. So although May is our 5th month, t equals 4 means that we're 4 months after the 1st of January, which means that it first occurs on the 1st of May. Now, obviously, these are very nice temperatures that wouldn't actually happen in real life, but this is just basically a modeling. So, 2-mark question. This is your 2nd mark, the answer. Your 1st mark comes when you recognize that t is equal to that. Let's jump straight into D. I'm not going to rub the question out this time. So, what does D give us? So we've got this, during the winter months, for how long does the mean daily maximum temperature remain below 15 degrees Celsius? Give your answer correct to 2 decimal places. Awesome. So let's just have a look at the graph first because it helps to kind of visualize what is going on here. So this graph, we've got our middle point at 24, got our max point at 36, and our minimum point at 12. We've got this median here. This is our t, this is our t. Awesome. And it's a positive cos graph, which means that it starts like this. Okay? So during the winter months, for how long does the mean temperature remain below 15 degrees Celsius? So 15 degrees Celsius is somewhere here and somewhere here, which means that we're looking for this amount of time in between here, because this is the time that the temperature is below 15 degrees Celsius, right? So basically we need to figure out where these happen. So let's do that by subbing in 15 into our temperature, which means we get 15 equals 24 plus 12 cos of pi t on 6. And keeping in mind, guys, that we're going to be giving our answer correct to 2 decimal places, which means we're not going to have a very clean answer. So from here we get negative 3 on 4. So obviously I'm skipping a couple of steps here, guys, but I'm sure you can keep up with me. So negative 3 on 4 equals cos of pi t on 6, which means that pi t on 6 is equal to the inverse cos of negative 3 on 4. Just coming up here, guys. That was weird. We get pi t on 6 is equal to 2.41886, which means that t is equal to 4.61968. This is your first mark right here. So finding out this first value of t. So this is what we've just found out now, this first value of t here. So according to our graph, this minimum occurs at 6 because our period is 12, okay? Because 2 pi over 6 is 12. So our period is 12, which means our minimum occurs at 6. So this bit here is our 4.6, etc. Which means that this point here has to be the same distance away from 6. Does that make sense? So from this point to this point is the same as this point to this point, and we know what this point is. So the distance here is equal to 6 minus 4.61968, and then that's this bit here, which means that this total distance will be 2 times this. So this times 2, which gives us 2.76 months. Again, do not forget your units of 2.76 months, but this is our final answer, and this is a 3-mark question. Your 2nd mark comes when you recognize this bit here. So your 1st mark comes by subbing in 15 and getting the value of t. The 2nd mark comes when you recognize how that actually relates to the graph, and then the 3rd mark comes when you actually give your answer correct to 2 decimal places as well, so don't forget that either. Guys, that's it for MM133. Please hit me up in the comments below if you're not too sure of anything I've done, but otherwise, have a great day.